Hi guys, I'm going to go through Regents Prep 9, starting with the multiple choice. So it says a solution. So I'm thinking, well, what is a solution? An example of something that's a solution would be if it is aqueous, which remember means it's dissolved. So will they separate on standing? No. May they have color? Yeah, maybe. Cloudy? No, I don't like cloudy because I won't see anything if it's aqueous because everything will be dissolved. And can be heterogeneous. Nope. Solutions are always homogeneous. So it is not 1, 3, or 4. So it's 2. Remember, if they have color, we're thinking those are transition metals will often have color. So that's just a good review. Number 2, when a teaspoon of sugar is added to water in a beaker, the sugar dissolves. The resulting mixture is. So we're going to focus here on the sugar dissolves. So since it dissolves, it is a homogeneous solution. Remember, homogeneous and dissolves, because I can't see the difference. Okay, number 3. What happens when a crystal of salt, here I'm going to change this a little bit. What happens when a crystal of salt is dropped into an unsaturated solution of the same salt? So it was unsaturated. So if I put in a crystal, and where it says excess solute crystal form, it's not that. That would be if it's super saturated. The crystal dissolves. Yeah, I like that for unsaturated. Crystal drops to the bottom unchanged. That would be saturated. And the solution becomes colorless. That's probably using maybe an indicator or something, but definitely not what we're talking about here. So I like choice 2. The crystal dissolves. Unsaturated, you want to think not full. All right, number 4, as the temperature of liquid water decreases, the vapor pressure. So we're talking about water. The temperature is decreasing. And they're talking about vapor pressure. If I want vapor pressure, I'm going to think about going to table H. We don't often use this table, but H is the vapor pressure of 4 liquids. So I'm going to look at this, and we're saying our temperature is going to decrease. So let me back this up a little bit here. We can see here I have the curve for water, and as I increase in temperature, my pressure seems to increase, and as I decrease my temperature, my vapor pressure is definitely going down. Check these places. Look, here it's at 101.3. If I go down to 75, it's at about 55. If I go down to 50 degrees, it's at about 10 is my vapor pressure. So table H proves as you decrease your temperature, your vapor pressure goes down as well. All right, let's see here. Number 5. What happens when a crystal of solute is dropped into a supersaturated solution? So if it's supersaturated, that means it's overfull, or it's super full. So if I put more in, remember we saw videos of this. I like choice 1, the excess crystal form. Remember, everything kind of falls out of the solution and it becomes a saturated solution instead. Number 6, which compound becomes less soluble in water as temperature of the solution is increased? So if they're talking about less soluble, they're talking about temperature of a solution, I want to think that I can go to my table G. Let me flip here. Table G has my solubility curves. So I'm going to just check these curves. So less soluble as the temperatures increase. I'm going to actually do this by showing you the correct answer, which would be choice 1, HCl. Because if I look at my HCl line, this is my HCl line, and if I look at it, raise it up a little bit, as temperature goes up, my solubility actually goes down as temperature increases. So less soluble as the temperature increased. And that was looking at table G. Seven, nonpolar solvents most easily dissolve solids that are. So if you're nonpolar, I want to think, okay, if I'm talking about what dissolves, I want to think like dissolves like. And if I'm talking about like dissolves like, and something's nonpolar, that means I want nonpolar will go in something that's nonpolar. So nonpolar and nonpolar. So I'm going to scan here and I don't see nonpolar, but I do see covalent. And remember that covalent kind of breaks into two categories. It can be polar or it could be nonpolar. So because I want it to be nonpolar, I think choice 2 is my best answer. 8, the depression of the freezing point is dependent on. So when we talk about depression of the freezing point or elevation of the boiling point, we're talking about, remember we had our little alligators? Boiling point is going to increase and your freezing point is going to decrease when you put something in your water. So I like the nature of the solute because it depends what I put into my solution, and I also like the concentration of the dissolved particles. I don't like the formula mass or hydrogen bonding. I don't care about those. So I'm between choice 1 and 2, and both of these are important. If I had to choose, I would pick choice 2 because the concentration of dissolved particles, I want to think ionic is better, and then more ions is better. So the nature of the solute, you're basically thinking ionic versus something that's covalent. Ionic's going to be better. But here, ionic, and it depends if I have more ions. So that's the most. But I also would accept choice 1. So this was accepted as well. This is the best answer. 9, as temperature of the liquid increases, the amount of gas that can be dissolved. So gases are special. If you decrease your temperature, you're going to increase your solubility. A can of soda or something like that is the best example. But if you can think on table G, NH3 is a gas, and you can see that line decreases. So as my temperature goes up, my solubility, which is over here, actually decreases. So NH3, so that could help you. So temperature decreases, solubility increases. We did the other relationship. So 10, under which conditions are gases most soluble in water? So again, for gases, they're special, they're most soluble. If we think about the temperature, again, I go to my table G, remember NH3. So I can see that I can fit more as my temperature actually goes down. So I want low temperatures for sure. So I'm going to get rid of 1, I'm going to get rid of 2. And then I want to think about my pressure. Well, pressure affects gases, and high pressure is actually better. So I don't like low pressure. I'm going to go 3. Example of the high pressure, you could think that a gas in a solution would be carbonated soda. And so it's at a high pressure on the can, you open the can, and you release the pressure. So a soda can would be an example of this. Okay, moving on. Number 11, at standard pressure, how do the boiling point and freezing point of NaCl aqueous compare to H2O? So NaCl aqueous, remember that means I have NaCl and it's dissolved in water. So here I have salt in water, here I just have water. And anytime you add something to water, you're going to think we've got our little alligator. My boiling point goes up, my freezing point goes down. So the something in would be better. So the boiling point of NaCl aqueous is lower. I don't like that. Both the boiling point and freezing point are lower. Nope. The boiling point of NaCl is higher. I like that. And the freezing point is lower. I like both of those. Choice 3. 12. The diagram below represents an ionic crystal dissolved in water. According to the diagrams, the dissolving process takes place by. So how do things dissolve? Well, they call this an ionic crystal. So there's your ion, and a water molecule. So this dissolves by choice 4, molecule-ion attraction. The molecule is your water. The ion is your crystal. Number 13. Which substance increases in solubility as temperature decreases? So it's going to get more soluble as temperature decreases. It's going to be choice 2. I'm going to show you this on table G. So if I look again, we've been using this example. Here's my NH3. So at 100 degrees Celsius, I can only fit about maybe 8 grams in. Let's see, at 50, I can fit about 28. At 30, I can fit about 45. So I'm going up as I do that. So NH3, table G. 14, a saturated solution of potassium chloride at 10 degrees Celsius is heated to 30. So it was at 10, it's heated to 30, and it is potassium chloride. As the solution is heated in a closed container, the total mass of the solution, remains the same. You didn't do anything to it. All you did was heat it. So you didn't add any more and you didn't take away. You only heated. So only heated, didn't add or take away. This is a trick question. Don't let them trick you. 15. Solution of barium nitrate and sodium sulfate are mixed, and they're going to pour it into a filter. The solid that remains on the filter. So I actually want to think they're taking, okay, barium nitrate, Ba, NO3, 2. Pouring together with sodium sulfate, Na2, SO4. What does it form? This is going to go through a double replacement reaction. So remember that means two things switch. My Ba is going to go with my SO4. My Na is going to go with my NO3. So I'm going to get NaNO3, and I'm going to get BaSO4. Now, this is kind of complicated because I also have to go to table F and look at my solubility guidelines because I want a solid that remains. So basically, I want something that's going to be a precipitate. So I want something insoluble. So let's see if NaNO3 or BaSO4. So here, when I look at table F, I can see that my SO4s are going to be soluble, but an exception is Ba. So if I have BaSO4, that means it changes the soluble sulfate into something insoluble. So Ba is the exception. So barium sulfate, choice 4. We'll kind of make that Ba exception. And that was on table F. So this was kind of a complicated question. I had to do a double replacement and I had to go check table F and see who would be soluble. 16. Student drops a crystal of NaCl into a beaker of NaCl aqueous. The crystal dissolves. The original solution must have been, well, it must have been unsaturated because that means it's not full. Because if this dissolves, that means there's more room in it. 17. A solution consists of 0.5 moles of CaCl2 dissolved in 100 grams of water at 25 degrees Celsius. Compared to the boiling point and freezing point of 100 grams of water at standard pressure, so I'm looking at boiling point and freezing point, the solution at standard pressure has, well, remember, we kind of explained that up here. My little alligator, remember? Can't see my hands. But as the boiling point increases, as your freezing point decreases, so we're going to say increase BP, decrease my freezing point, So it has a higher boiling point and lower freezing point. Trisha? Question 18. A student tested the solubility of a salt at different temperatures, then used the physical setting reference table to identify the salt. The student's data appears below. So what is the identity of the salt? Well, this is the solubility in 10 grams of water. What they want us to do is really go and compare it on table G. They want us to look here, but remember on table G, it's in 100 grams of water. So really, if I want to do it in 100 grams, 100 grams of H2O, then I would really have 12 grams out of 22 grams, because I multiply by 10, 30 grams, and I'd have 40. So what you're going to do, you're going to go to table G, and I'm going to find each of these points. So at 30, I'm going to look at 12. So 30, I look at 12. Oh, I can't see it. 30, I look at 12. Then I'm going to go 50, I'm going to look at 22. I can already see I'm traveling on this line, and this line is KClO3. So KClO3 is potassium chlorate. 19. What happens when Ki is dissolved in water? So Ki, I want to think that's ionic because I have a metal and a non-metal. So that's going to break apart into ions. So break it into two pieces, K plus and, I is the other one I'm looking at, I minus 1. So they want to say, well, who's attracted to water? So if I were to draw water, remember that water is polar. That's very important. Some of you have forgotten that recently, but water is polar. That means water has a partial negative O and a partial positive H. So if I put Ki in there, opposites attract. I'm going to note that. So my K plus is going to want to be attracted to my O, and my I minus is going to want to be attracted to my H. So the I is attracted to oxygen, nope. The K is attracted to the hydrogen, nope. K attracted to the oxygen, I like that. No attractions, I don't like no attractions, because this is ionic, that's polar, so I like choice 3. This is actually molecule ion attraction. 20. Which two compounds contain only polar bonds? I don't think we'll find have polar bonds. I want to have electronegativity differences between 0.4 and 1.6. So I'm actually going to go ahead and I'm going to look. This would be on table S. Table S is going to show me that. So I'm going to look. I should show you. I'm going to do just one example. Just one. So for example, if I was looking at the difference between C and O, I'd go here and I'd say, well, C has an electronegativity of 2.6. O has an electronegativity of 3.4. So I end up going 3.4 minus 2.6. That's going to give me an electronegativity difference of 0.8. And this would also be a CO bond, so that's also 0.8. That's going to fit into that range. So I really like choice 4. Although, if I look, let's see, N. 3.0 H is 2.2. That's going to be 0.8, and H and Cl is, sorry, I'll do it over here. 3.1 minus 2.2, that's 0.7. So actually, I would accept that as well. So for this question, you can do 3 or 4 because both of those only contain polar bonds. 21. Water boils at 90 degrees Celsius when the pressure exerted on the liquid equals. So they're talking about a boiling point and a pressure. Go to your table H. They want to know when water boils at 90 degrees Celsius. So I'm going to flip there. And at, let's see, 75, 80, 85, 90. So at 90, go up to your water line, go over, it's about 68, no, 50, 68, sorry, 68 kPa. No, it isn't. It's right on it. 70. Choice 1. 22. If 100 grams of water at 80 degrees Celsius contains 45 grams of KCl and 45 grams of NaNO3, the solution is. So 80 degrees Celsius. I'm going to go and check these temperatures and these masses on table G. And I'm going to see where they would fall. So if I go to table G, let's look at 80 degrees Celsius and 45 grams of KCl. So 80 degrees Celsius, 45 grams, that'd be right about here. Here, I'll put the dot right on there. That's below the line, so that would be unsaturated. So KCl is unsaturated. Let's check my NaNO3, 45 grams of NaNO3. So 80 degrees Celsius, 45 NaNO3. Ooh, that line's way up here. It's not even on my screen. It's way up here. So that's going to be below that as well. So it is unsaturated. Choice 3 with respect to both KCl and NaNO3. And they are both below the line. 23. Which sample of ethanol will have the highest vapor pressure? Again, vapor pressure, we're talking about ethanol. Go to table H. You're going to check on table H which one has the highest vapor pressure. So really I'm looking at these temperatures. So as I go to table H, I see that as my temperature increases, I'm going to have the highest, my pressure is going to increase as well. So if I go there, choice 1. 24, the vapor pressure of water is 50. The temperature of the water is, again, vapor pressure. I'm going to table H, but I'm going to look at it for water and look at it at 50 kPa. So 50 kPa, I guess I go there, would be here. Go over till we hit the water line. It's the third one over. It's right here. So I'm going to read that, and that is approximately 82. Moving on to the short answer. So it says a scientist makes a solution that contains 44 grams of hydrogen fluoride gas in 200 grams of water. The process is represented in the balanced equation below. Based on table G, identify in terms of saturation the type of solution made by the scientist. So if I had 44 grams and 200 grams of water, that actually means that I'm going to have 22 grams in 100 grams of water. So I'm going to check, and they said it was at 20 degrees Celsius. So let's go check HCl at 20 degrees Celsius. So let's see, 20 degrees Celsius. Oops, I'm on the wrong table. Silly. 20 degrees Celsius. 22 would be right about, I'll put the dot on, right about there. Here's my HCl line. So that means it would be unsaturated because it is below the line. So 26, explain in terms of the distribution of particles. So in terms of, that's important. Why the solution is a homogeneous? Well, a homogeneous mixture means it's dissolved. So distribution of particles, you could say they're all dissolved. Or you can say they had an even distribution of particles. Even distribution of particles. Really think if it's homogeneous mixture, it's saturated. Dissolved is important, so I can't see the difference. So either of those would put it in terms of distribution. 27. Knowing the gram formula mass of HCl is 36, determine the molarity. So they want molarity. So I'm going to go to my table T. And actually, I'm going to have a different reference table. On table T, let's see. Relative concentration, molarity, is moles of solute per liter of solution. So I have, let's see, I'm going to do this right down here. So molarity, oh, okay, this is a little tricky, is moles over liters, but they gave me my gram formula mass, and I know a mass, so, okay, we better actually find our moles first. So moles is your given mass over your gram formula mass. So the solution was 44 grams, so 44. Gram formula mass is 36. So let's see how many moles we would have. So first, I would get 1.2 moles. Okay, so now I have 1.2 moles. Now I have what I need over here because I also have a volume. It was 200 grams. So 200 grams of water, 200 grams equals 200 milliliters of water because of the density. This is really tricky. So 200 milliliters is really 0.2 liters. Ooh, this is a tricky one. So my moles is 1.2. My liters is 0.2. And so I'm going to get 6 molar. That was a tricky problem. Okay, 28. Which solution has the lowest freezing point? Explain why. Well, I'm going to think lower freezing point. I always want something that's ionic, so I'm between one of these two. And then I want to think, okay, look at what they're made of. KCl and BaOH2. So it's going to be the BaOH2 because it's ionic and it's actually going to split into the most ions. I'm going to have one Ba and 2 OHs, whereas here I'll just have a K and a Cl. So BaOH2 because I'm going to have the most ions. 29. Solution A is unsaturated with 74.54 grams, 1 mole, of solute dissolved in 1 liter of solution. According to table G at a temperature of 30, how much additional solute would be required to saturate the solution at that temperature? Alright, so we had 74.54 grams in 1 liter of solution. Well, 1 liter, remember, is 1,000 milliliters, which from this problem we just did up here, I know 1,000 milliliters is equal to 1,000 grams. So when I look on my table G, this is in 100 grams of water. So when I look on table G, I actually want to see at 30 degrees Celsius, I want to saturate it. So let's go 30 degrees Celsius and say, well, how much would I want in it? 30 degrees Celsius, KCl, right here, I'd want about 35 grams. If I was putting it in 100 grams of water. But I'm not. I'm putting it in 1,000 grams of water over here. So I'm going to multiply that by 10, and I'm going to convert that, and so then I could fit 350 grams in 1,000 grams of water. So let's see. Now compare it. I had 74.54 grams. I can fit 350. So another tricky problem. I go 350 minus 74.54, and I'm going to get 275.46. 275.46. Another really tricky. But we're ready for them. So it says the following graph, so it's on the other page, gives us the solubility curve for substance X. Points A through F represent various solutions at different concentrations. Okay, so let's look at it. Here it is. State the letter that indicates the position on this graph where substance X is saturated. Well, if it's saturated, I'm going to think it's on the line. So who's on the line? A is on the line, and F's on the line. So you only said one letter, but so you could say A or F. Either one. 31. Describe in terms of solute and solution interaction what would happen if additional solute crystals were added to the solution at point B. All right, in terms of solute and solvent, all right, let's see. So at point B up here, okay, would be supersaturated. So if additional solute crystals were added, that means excess solute is going to fall out of the solution. So excess solute will fall out into the solution. I think that's perfect. You're talking about the solution, so that gives you kind of the solvent. The solution is your solute and solvent. Your excess solute falls out, leaving you with a saturated solution. I'm sorry, you couldn't even see that. Well, hopefully you could hear it. 32. What could be done in the solution at point D to make the solution saturated? So I want to think, well, point D is right here. And to saturate, I could do a couple things. I could lower the temperature. So if I decrease my temperature, I could saturate it. So decrease temp. Or I don't have enough, so I could add some of this solute in here. So, or add more solute. Either or, one of those two things. Okay, so they tell me a little bit right here. I'm probably going to have to refer back to it. They have 75 grams of solute. They make up 0.25 liters of solution, and they give me a gram formula mass. So this is determine the molarity of the solution. So molarity is moles over liters. But I don't know my moles. I know my grams. So first I get my moles. So moles is your given mass, which was 75, over your gram formula mass, which is 122. That is going to get 0.61 moles. So then I can plug that in. So 0.61 moles over, it said it was in 0.250 liters of solution. So I'm going to plug that in, and I'm going to get my molarity is 2.44 molar. 34, determine the percent by mass oxygen in the solute. Remember your solute, let's see, it was KCl of 3. Let's write that. The percent by mass of oxygen. Again, I can always go to my table T, percent composition, percent by mass, part over whole times 100. So, let's see, my percent, all right, so my oxygen here, I would have is 16 times 3 over my mass of my whole. Well, K has a mass of 39 plus CL has a mass of 35.5 plus there were those 16 O's, or I'm sorry, a mass of 16 times 3 O's. So we have basically I'm doing 48 over 122, which is going to give me 39.3%. Okay, miscellaneous questions, almost done. State the relationship between solubility of sulfur dioxide gas and temperature. Well, for this, go to table G. If you go to table G, I'm looking at sulfur dioxide, SO2. SO2, the curve goes down, so as you increase your temperature, the solubility decreases. So increase temp, decrease solubility. 36. What is the boiling point of propanol at atmospheric pressure of 70 kPa? For this, go to table H, and you're going to look, boiling point, it says propanol. So table H, I'm going to go there, 70 kPa. Here, propanol, I'm going to go to the line. I'm going to go down to my temperature, and that is at 45 degrees Celsius. 37. Describe the effect of solubility of KMF3 solid in water when the pressure is decreased. Well, it's a solid. So pressure only affects gases. So only gas. So what I want you to say is no effect. It will do nothing because it's a solid. Last one. Describe one way to make a saturated solution of NH3 in 100 grams of water at 60 degrees Celsius unsaturated. So it's NH3. I want to make it unsaturated. Well, let's look at the solubility curve. So if I'm looking at the curve for NH3, let's see. 60 degrees Celsius and NH3 right here. So I can fit about 22. If I want to make it unsaturated, it means I want to go below the line. Well, what I could do is I could, let's see. I could lower the temperature because if I want to make it, no, I could raise the temperature, sorry. I want to, what do I want to do? I want to make it unsaturated. Okay, I want to make it so that I can fit more. So if I can fit more, then I want to say, okay, I can decrease my temperature because more would fit. So I could lower the temperature. Or, if I want more to fit, I could add more water. Because if I add more water, more will fit. If I'm unsaturated, it means it's not full. So I could do either of those things. And that concludes Regents Prep 9. So hopefully you learned a lot about solutions. This carries into our acid-base unit. Thanks so much for joining me. On to the next one.